This video, we're going to start looking at logarithms, what a logarithm is, how to work with logarithms, how to solve logarithmic equations. In our next video on logs, we're going to look at graphs of them. So what is a logarithm? Well, a logarithm is effectively the inverse of an exponential equation. The usefulness of logarithms is that we are using them for very large quantities, things like magnitude of earthquakes. Where the exponent is going to be more valuable than the actual number itself. So how do we work with logarithms? Well, first things first, we have to understand that this is an exponential equation right here, and this is a logarithmic equation. There are certain pieces that are exactly the same. So we have, usually our output is listed right here. We've got our base, we've got our exponent. The logarithm, we have our exponent becomes our output, is the log base, right? There's our base, and then of our number. And important part is that b cannot equal 1. So these are examples of exponential to logarithmic conversion. So y equals 2 to the x becomes x equals log base 2 of y. 2 to the x equals 16. Log base 2 of 16 equals x, which we can find out is 4. We're going to do some solving there in just a little bit. 3 to the 4 equals 81. The base log would be log base 3 of 81, and that should be equals 4. So those are some conversions. So how do we convert these? Rewriting an exponential form from a log. Essentially what we're going to do is we're going to take our base and we're going to loop around to our exponent, and that's going to equal our number. So if I rewrite this as an exponential function, it'd be 3 to the 4th equals 81, which we know is a true statement. I can do the same here like this one, 8 to the 3rd equals 512. Even with fractions, I can do that. Log base 16 of 8, so it becomes 16 to the 3/4 equals 8. Log base 5 of 1/25 becomes 5 to the negative 2 equals 1 over 25. Again, using our negative exponents, we know that's true because that negative 2 exponent is going to bring it down to the bottom. For writing in logarithmic form from exponential, the first thing I'm going to do is write log, and I'm looking for my base. My base in this case is 2 of my number equals my exponent. And I can always double check. I can always take that logarithmic equation and convert it back to an exponential. 2 to the x equals 8 absolutely works out. Let's do this one, part D. So we've got log, our base is 125 of 5 equals our exponent, 1/3. How about F? So we've got log base 6 of 1 equals 0. Now, it doesn't matter. This is a very important one. It doesn't matter what your base is. If you're taking the log of 1, your exponent is always going to be 0. Anything to the 0 power is 1. So I can make that like 8,427 to the 0 equals 1. My log expression would be log of 8,427 of 1 equals 0. It has to. Log of 1, no matter what the base is, has to equal 0. So we can evaluate. Now, the way we're going to evaluate is on these equations, I'm going to effectively convert them to exponential equations. So to do that, though, I have to make an equation. So I'm going to set this equal to x, and I'm going to loop around. So that's going to give me 2 to the x equals 16. Now we have to think back on how do we solve exponential equations. In order to do this, we have to have a common base. So on the left side, I've got a 2. I think I'm good with that. I can't make that any smaller. But on the right side, I can turn 16 into a power of 2. And that would be 2 to the 4th power. Now, if the bases are equal, then I can just set my exponents equal. So x would equal 4. And that's what the logarithm will equal. So in other words, the exponent of 2 being 4 would give me 16. Let's pick another one. Let's pick part D. So again, I set that equal to x. I'm going to take that as 1/2 to the x equals 256. Now this one's going to be a little bit more complicated because of that 1/2. What I'm going to do is try and turn them so that they're base 2. 1/2 is really 2 to the negative 1 power. So I can make this 2 to the negative x, and 256, I got to think about this one, but I believe it's 2 to the 8th power. If you're not sure, you can always kind of count them out and figure out what the power is going to be. Now again, because the bases are equal, I can set the exponents equal. Negative x equals 8, and x would equal negative 8. And the last type of this type of question is one where we're going to have a square root or radical of some sort. What I'm going to write out here is, again, the same thing, x. And we're going to loop it around. 10 to the x equals the square root of 10. Something you got to keep in mind as we go through. The square root of x is really x to the 1/2 power. Your exponent here is 1. Your index, which isn't written, is 2. If we have like the cube root of x, that would be x to the 1/3 power. Exponent of 1, index of 3. Similarly, the fourth root of x would be x to the 1/4, and so on. I could even throw in one like the cube root of x squared. My exponent is 2, and the index is 3. That'd be x to the 2/3 power. So using that idea in this one, we'll have 10 to the x equals 10 to the, well, it's more like this type right here, 1/2 power. My bases are equal. Set my exponents equal. X would have to equal 1/2. All right, so the last type of question we're going to look at is solving an actual equation. So we kind of cheated a little bit there and we set up an equation. Not really cheating though, it is what we need to do. What we're going to try and do is solve different types of equations. I'm going to pick this one because it's got a base there. I'm going to pick this one because we're looking for a number. And I'm going to pick this one because we're looking for the exponent. So I can set up these 4 different equations. Again, I'm going to loop it around and set up an equation and try and make it work. X to the 4th equals 81. So what I'm looking for is a number that when I take it to the 4th power gives me 81. So I can think about 2 to the 4th power. That would be 16. That wouldn't work. 3 to the 4th power. So 3, 9, 27, 81. Yeah, x to the 4th would be the same thing as 3 to the 4th. So again, my bases are different in this case, but my exponents are equal, so my bases must be the same. X equals 3. On part B, I'm going to loop it around again. 4 to the negative 4 equals x. And so I'm going to try to figure out what 4 to the negative 4 power is. Well, the way to do that is I'm going to take 1 over 4 to the 4th power. And I don't immediately know that off the top of my head, but I know 4 to the 1st is 4, 4 to the 2nd is 16, 4 to the 3rd is 4 times that, which is 64, and then 4 to the 4th would be 4 times that, which is 256. So I'm going to get 1 over 256 is equal to x. And then part F, same idea. We're going to loop it around. 16 to the x equals 8. Now, it's not easy to convert this one so that we have the same base. So I'm going to go to a smaller base than 8 because I can't convert 16 to a base 8. So I'm going to convert those down to a base 2. So 8 I can make 2 to the 3rd power, and 16 I can make as 2 to the 4th power. And I'll take that to the x power. So I'm going to take this and make it 2 to the 4x equals 2 to the 3rd. My bases are the same. My exponents have to equal. 4 to the x equals 3. And so then x would have to be 3/4. And it is okay to get fractions. You're going to get them every once in a while for your exponents. There's one I actually want to talk about that just caught my eye, part D, because they don't tell us what the base is. Now, if they're not going to tell you what the base is, if it says log, that means it's going to be base 10. You could also see something called natural log, and that would be a base e, and that's not something we're going to talk about right now. But e is a number. It's a very complicated number, but it's another number we can use for our bases. So to create this equation, I'm going to write that as a 10 and loop that sucker around. 10 to the x equals 1,000. And I think I can convert those to base 10. And it looks like 1,000 would be 10 to the third. And so then x would be equal to 3. So again, logs, we're basically inverting them and turning them into exponential equations to make it a little bit easier for us to solve them.